now, and then I'll have that live here in Discord in just a second. And I'll drop the link in like I always do. Yeah, I got all stymied on my decision making right at the critical moment. All right, there we go. All right, everybody ought to be able to see that. And let me now go grab the link real quick and throw that down for you. Because I know we still got, okay. Where am I? All right. What's today? Tuesday? Oh, you know what? When last we met, I was about to go have my second Moderna shot. And you know what happened? Almost nothing. Little woozy Thursday evening. Crazy tired on Friday. Really, really tired. Slept like, I don't even know, a lot. Uh, nap plus 12 hours kind of thing. And Saturday, a little groggy. Boom, good to go. No fever, no headache, no nothing else. Nothing else. Even the arm soreness wasn't that bad. I think they gave me the placebo. They gave me the saline injection. I think the study's still going on. So I don't know. It was great. I mean, it was fine. I'm going to genetically mutate into some new creature, and I'm excited because I always wanted to breathe underwater, and fly. So I think my dreams are going to come true pretty quickly. So yeah, Josh, I think so. Let's go module 9. Okay. Texas man, I'm sorry, but I'm glad you got it. I hope we're all going to get safe and get some herd immunity and figure this stupid frickin' thing out because we've all been through serious hell. You know what I mean? We really have. All of us together have been through just stupid crap for the last year. And I understand that for me, it's less of it's a smaller percentage of my life than it is for you, for y'all's youngsters. But still, I mean, it's been just crazy. So I hope we can emerge back out and get our freaking collective social act together, and you know what I mean. I don't know. That's it. That's my little sermonette, eulogy, whatever, for the future. Um, yeah. All right. So here's the deal. Yeah. Okay. So there's no number 9 homework, Josh. Let's talk about this. Number 9, as the Beatles would say, number 9, number 9. Um, Go check out the White Album if that reference eludes you, and look for Revolution 9. It's not their best work. Um, so here's what we do. Here's what we do. Um, with number 9, I'm going to pull up the assignment for the final project. Okay. Uh, and we're going to walk through it. Now, the other thing Walter, I don't know, man, if we've got, wait, we don't have 4 after this, don't we have? No, we have 4 after this. Because we got Thursday, then we got the following week, Tuesday, Thursday. The following week is just Tuesday. Yeah. Okay. So what I want to try to do today is talk about the that final project thingy, which is a good opportunity to talk about design. It's identified as large program. Here you go. And so I'm going to blow this thing up. Um, is that okay on visual? Is that adequate for visibility coming through on Discord? I can blow it up, then I just I lose words on the page is all. Uh, what do you think? How's that? I can't see what you see.
I can't see anything right now. That might just be me though.
You mean you can't see
Yeah,
any?
it looks decent to me.
It looks what to you?
Looks decent.
D's. Gotcha. Yeah, thanks for that interpretation. I got it. At first I didn't. I just didn't hear it because I'm old and my hearing shot. I'm gonna go up. I'm gonna bump it up one more for just a little bit of extra granularity. Okay. Um, it's a little long, right? It's a little long, and so I want to talk about this. This is Module 9. And so the way Module 9 works, okay, listen very carefully, children, to a story about Module 9. The way Module 9 works is there's not a homework thing. You know, Walter, I don't think we actually implemented it. We talked about doing something like, wait. Did we do a Module 9 homework, Walter, where you had to kind of just drop in some like design notes and things just to start working? I'm having a flashback.
Not when I took the class.
Well, you got off easy, my friend. No, you didn't. Um, I want to see something. Let me see. Yeah, there is no homework for Module 9. I think, Walter, I think it was maybe just something that we just like talked about or something and didn't actually do. Or no. You know what it was? No, it's set up, it's sitting there as exam module 9. Okay, hold on. I'm going to change this right now. Because it needs to be, what do we call these things? Hang on. What do we call these things? Homework module. Oops, that's not what I'm doing. Hang on. Homework module 9. Yeah, we did do this, I think. Yeah. Okay, and I'm just moving. I think it's in the wrong group because I'm a dum-dum. Display groups as points. Yeah. Okay, and then that's going to be, it's going to have a due date, but like everything else, it's not, you know what I mean? It's not like a strictly enforced thing. It's a reminder to get the dang thing done. Okay, and I don't even think I need to say anything there. Oh, actually, okay, April 28th. Okay, what I just did was I saved, hang on a second. I don't know why it was over there in the module exams, maybe because we were treating it as such, but there's homework module 9 now, and I'm going to put it down there. I think I had it actually, I think I remember now, I think I had it in the module exams because the idea was that once you like uh, did the program, submitted a program. And so if you submitted a program and you had done like 8 and 10, we would just give you credit for the module exam for module 9, basically. So that, and I think the way that we're going to do this now is if you submit the homework for module 9, which let's walk through that real quick. And this is going to relate to what we're talking about today. I want a state diagram. Remember we did state machines. So just a state machine of your algorithm, and it's going to it's just scratch paper. It's just your notes about how to do this thing for yourself. It's not qualitatively graded. It's not like, wham, I don't like your notes, okay? If you did it and you submit it and it's stuff that's just been useful to you, that's fine, and we'll give you the points, okay? It's just an attempt to say you got to be given some thought to this project before you do the thing, and therefore uh, um, give you some credit for that. Call that the homework. Having done that and then having submitted the program, you get credit for exam 9. There is no module exam for 9. Everybody clear? No module exam for 9. You do the homework and you submit your program, and that gets you the module exam for 9. Okay. But I do want you to draw a state diagram, because we're going to talk about today is the fact that, wait, I thought I already moved that. Did I not? I thought I already moved this down here. Okay. And then here we go, large program. Let's go large program. Okay, any questions about that? Are we good? It's not super complex. Okay, here we go. Large program. Let me kind of break this down for you, what this is trying to be, why we're doing this exercise, okay? First of all, I want you to be able to do a slightly larger program, okay? Now, I'm going to drop I know we're thin on numbers. The numbers have been thinning constantly. I want to just do a real quick thing here. It's a survey. I'm dropping it into the chat. I have personally used the LC3 simulator before this moment. Yes, no, okay, and at least the yeses, if I could, and I'll add a reaction to start the ball rolling. Thank you for the N. I mean, it's the wrong answer, but thanks for getting the thing rolling. Come on, man. Where's my? Can we get a yes? There's a yes. Okay. Yeah, and if you're kind of still new to Discord, just click on the Y or the N, and it'll kind of tally up. I'm just trying to get a sense of how valuable this can be, and I do want to start cranking it. And Walter, we have not yet put our modified version into a hosted position, have we?
Not that I know
I
of, no.
know we talked about it, but it's okay because I can still run with the one that's on GitHub. All right, 10 to 4. And then we've got 3, 6, 15. We got 18 bodies here, 17. That's actually not a bad representation. There's always a couple that are fall asleep or whatever. Okay, so what I want to do is I want to at least open up the LC3 simulator. You cannot do the homework. I think it starts with the assembly programming one. You can't do the homework without using the LC3 simulator. And I want to just sort of demystify it for you just a little bit. For the 4 who have used it, any personal testimonials? You struggling? Is it pretty easy? What's kind of happening? So Texas says it's super easy. I concur, okay, with I'm Team Texas on this one. I think it's pretty simple tool to use. All right. But so let me do this. Let me just do this. Let me talk about the program first, then I'm going to pull up the LC3. Okay. When you have an assembler, remember that back in the day you had hardwired programming. You'd run patch cables, you know, and eventually it was like, no, what we can do is we can just load bit patterns into memory. That will be the program. That was the von Neumann architecture. That, like, the idea that I could have memory and data in the same space, then I could just set up this program counter that would do this fetch, decode, execute, and just go there, grab the bits, and that would tell the program or tell the computer what to do. Then grab the next one. When you live in a world where your programs were literally rerunning patch cables for the programming, this was quite an innovation, okay? Well, once you started doing all that binary crap, as you've been doing, and I do use binary crap as a term of endearment, it is kind of crap, you know what I mean? It's not like what we all want to be doing. There are better ways. So then that led to assembly language where you could actually type characters, ASCII characters, like, AND space R1 space R2, stuff like that, and like way understandable. Then you needed to have a piece of code, right? A program that would process that, right? That would take that text, because all you're really submitting is text. That could take that text and turn it into machine language, right? Machine code, which is the exercise we did. We stepped through that last time, I think. Yeah, it was last time that we did that. Okay, well, what we're going to do is just write, this project is to write one little tiny piece of an assembler, right? It's very relevant. We could have you write some other random thing, but why not have you write a thing that reinforces a little bit about what goes on when you're doing assembling, right? When you take an assembly language code. I think we got Dallin. I think we got hot mic. Dallin?
No, sorry.
Shame. And so, right? So as long as, and the other thing about this process of understanding this, we reinforce state machines. You get to write a bigger program that has a little more complexity to it, or maybe a lot more. It's just bigger. And I would say in bygone days, when we were stuck using the LC3 simulator on GitHub, I think, Walter, it seemed like the average length on these things tended to be about 500 instructions. Seemed like ballpark, give or take. And the average time to write this thing was 5 to 10 hours. Does that seem, am I right, Walter? That seems right. Low end was about 5. High end is unbounded, because if you don't know what in the crap you're doing, you can twiddle your thumbs for a long time, right?
Yeah, I think it took me about 10 to 12.
Okay, yeah, not that wasn't unusual. That wasn't like out of some weird statistical distribution, like you were a high-end outlier. The first time I did it, it took me 6, and I did it like I started in about 1 in the morning, and I was done at 7. Well, it worked at 7. It sucked, but it worked. And I think that what I'm going to show you with the new assembler, we've made some adjustments to the old one. There's some architectural things that I think are going to make it a lot easier conceptually to do, which I'm going to try to help you with and have that cooked this week. So the idea is, so just kind of reading here, one of the things an assembler has to do is take instructions like add and jump and convert those to binary opcodes, right? You got to convert it to an entire instruction. Opcodes are part of that. Each assembly instruction has a corresponding 4-bit binary opcode. You already know that, right? You know that add is 0001. If you've been awake, conscious, pulse during this class, you already know that one. Not like you have to memorize it, because we have the cheat sheet. And we know that, what is AND? 0101? And branch is like all zeros. Trap is like all ones. And then I'm done. That's about it. That's about all I've got, just like right here. So here's what you got to do. You got to write, okay, so for example, jump is 1100. Oh, there it is. I wasn't looking. I wasn't cheating. But you already know this, that there are opcodes that correspond to these little, these instruction names. We sometimes call them mnemonics. But, jump, add, and BR. All right. You're going to write an LC3 assembly language program that does the following things. You ready? 5 things. Let's walk through it. You prompt the user. You output a message to the screen. How do I do that? You do that with a trap instruction, which I'm going to show you how to do. It's going to prompt a message to the screen. It's anything you want the message to say, okay? And then the user types, and it asks the user to type an LC3 assembly language instruction like add. And then the user ends their input by pressing the enter key. Okay, so the user inputs their answer and presses the enter key. Excuse me for a second. I feel like I have a sneeze coming on. And you know that desperate feeling when you just need it to actually happen, but it won't happen? Okay, I think I'm okay. All right, everybody got that? They're going to type, and you're going to enter what they type, and then you're going to save that away, and they're going to press return, the return/enter key. All right. If the instruction that they typed is a legal LC3 assembly language instruction, then our program has to display the 4-bit code. So if I type and, your program needs to respond 0101. If I say add, 0001. If I say jump, 1100. Okay? That's it. That's the first part. Then, if it's not a legal LC3 assembly language instruction, they type Fred. Okay? Then you need to display, or ADDD, or Andy, or just N, AN, or add like advertisement, AD. Anything that isn't a correct instruction, you got to spit out some kind of an error message. It can be sophisticated, it can be simple. And then this is really important. After you're done, you got to loop back to the top and reinitialize everything, get everything cleared up, kind of ready to go, and then go again. And then you do this until the user types the string quit. Okay? 334 lines, Walter, that's pretty efficient. All right. Does that make sense to everybody? That's it. It's a little interactive thing. And I know that if you haven't touched the LC3 simulator, which most of you have not, right now it's just like, oh, how do we do this thing? And we're gonna jump over to the simulator like right now, start playing around, start actually doing some little programs. Okay, we're gonna do this right now. And time-wise, yeah.
So just to clarify, we're not actually having to make it like to take the add instruction and then perform the add instruction they give us. They give us an add and we're just barfing back the code. Numbers.
Yep, that's right. The Alex barf back principle. I say add, you say 0001. Enter your instruction. And I say and you go 0101. Enter your instruction. That's it. Pure barf back. Now, if you were really building an assembler, you would like take those 4 bits, you'd save them away. You'd look at the next thing, which you're expecting to be R something, right? Came back.
The audio just did something real weird. It cut out for a second, then came back.
Yeah, I'm back. These are my AirPods, and I generally really like them. But
yeah,
okay,
It's normal.
And the key is you got to keep going until I say quit. You got to keep going. That just makes it. Whoa! OBS just disconnected. My stream disconnected. What happened? Did I get like a what do they call that? The
power surge.
a power surge, a pulse of some kind. I mean, this. Wait. Hang on. I just realized I don't know if this has been rolling properly out the street. No, it's okay. Let me just set up just make sure my sound, because they're also every time the ear thing resets on my main settings, that's correct, in Discord, but the main settings get scrambled. There's a setting that I have that allows your audio to go into the YouTube stream. And I think that got reset and it should be okay now. It should be back. Okay. All right, my friends. That was weird, right? I lost like, what the crap? I don't know, had to be my machine. I don't know what the deal was. Okay, but I think we're good now. All right, let's go. Next ones, next requirements, and please jump in with any questions you've got, okay? Right here, it has to be case insensitive. So if they type any combo of the correct letters, whether they're upper or lower case, you got to be able to handle that, okay? So if I go all caps add, lowercase add, scrambled, capital A, little d, capital D, all of those are valid. Same with quit, okay? All right, everybody got that? And I know some of you are like, but how? Okay, we're going to talk about this. And we can do some help sections about this, okay? All right, next one. As the user types an instruction, now this is a key thing, and it relates to trap instructions, which we're going to touch briefly today and then dive into on Thursday. But with trap instructions, it's one trap instruction to read a character that you type on the keyboard. You're used to a world in which you type on the keyboard and it appears, right? You're in a Word doc or you're texting or you're doing whatever you're doing, and you type and you expect it to appear on the screen. But you understand those are two different operations. One is to read the keyboard and go, oh, I know what you typed. Another operation is to what we call echo, is what we call that, okay? When it says should echo, that's a technical term. To echo means I also need to spit that character out to the monitor, okay? You ever had situations where, you know, maybe it's a password entry, right? And you type and nothing happens? A lot of times they'll put the little dots so you feel like it's progress. But there are situations where you just type and nothing echoes anywhere. That's an example. It's reading what you're typing, but it's not, you know, spitting that back. Okay, so you're going to read the character they type, and you're going to spit that character back to the keyboard so that as they type it, it appears on the keyboard monitor. As they type on the keyboard, it appears on the monitor. I think I said that wrong like 4 times. Okay? If you don't do that, they won't see what they're typing. Okay, again, stop me as we go. If you have any questions, please stop me. These are just clarifications, questions that have come up. So it looks like a lot. Once you get into it, it'll kind of start to make sense. Okay, the algorithm you use for processing the text has to be a state machine. That came about because a few genius individuals, I mean that actually sincerely, these are typically really great students, like quite good, who, with their playful spirit, decided that what they would do is enter the string that the user types, and then they would just simply compare it to just basically write a string compare, a little string compare function that you pass in these two strings. You know, here's the string, here's what the user typed, here's what is legit, and now I'm going to like compare it to the first one, compare it to the second one, compare it to the string add, compare it to the string and. That's not a bad exercise, and string compare is a thing that you actually have to do in programming, in high-level programming. It wasn't the exercise that I wanted to have with understanding how a state machine works. So I made that one verboten. You have to use a state machine. Okay. Now this next part, I'm going to break down a little in a lot more detail. Okay. If the user types an A, remember our discussion about state machines and state diagrams. Well, you're just in this state of the beginning state, the initial state. The user types a character. Based upon that character, you move to a new state. Okay? So if they type an A, upper or lowercase a, you move to the A state, because that's okay. Now, but if they typed like a Z, there's no Z instruction, then you would move to the error state, and then you would just be done and you would kick over and you would start over. Okay? So if they're in the A state, and at that point they can go to N, they can go to D, or they can hit the enter key. Sorry. They can go to A or they can go to D, and anything else they hit is an error. So you're either going to go to the end state, to the D state, or to the error state after they type a character when you're in the A state. I'll do A state this way. So we'll do a sign language A. So that's the A state, okay? They can go to N, to D, or to error, because the only valid places to go from the A state is to N and D. So they type N. Now I'm in the, I can't even do it now, right? I'm in the AN state. I can't do that with one thing, right? But I'm in the AN state. In the AN state, there's only one valid thing that can happen, and that is that they press the D key. That gets me to AND. If they do anything else, it's wrong. So anything else they do that's not the D key goes to the error state. Does that make sense? Now, when they've typed A and then N and then D, I'm in the AND state. There's only one thing they can now press that's going to be legit, and it is the enter key. Anything else they do. If they do that, then I'm in the AND state, the AND opcode state, which is like successful. At that point, to use Alex's term, I barf back 0101. And then I return to the initial state where I'm going to roll again. Okay? That's just, now if you think about this for just 3 seconds or less, you realize this is a big freaking state machine. Okay? It's a very big state machine because it has to handle essentially, it's like a decision tree really, right? All the places you can possibly go. This also gives you a really, really early insight into things like complexity theory and some things that you need to understand to be a good software developer and a good, whatever computer science means. To be a good one of those, you got to have a decent understanding of complexity theory. All right. Again, you know how this works. Stop me if you've got somebody. Stop me. Backspace doesn't exist for this project, Alex. Backspace is an illegal key. Yep, no backspace. And in fact, given the interface on the LC3, I mean, it's a clever idea, right? Like they've gone, they typed Andy and then the backspace and then enter. Well, if this were a word processor, right, that would be great. That would be fine. But yeah, for our purposes, it's, not a thing. All right, next one. Remember the BR instruction and how we talked about the fact that with BR, you could tack on the NZP. Well, you did tack on the NZP, bits by just tacking those. Typical convention with LC3 is lowercase. They're all articulated here. BR little n, BR little z, BR little p. You don't need to worry about all those. Just assume, again, for this exercise, they don't exist. The only thing that exists is just straight up BR. And the main reason is because I can make you do those. There's literally no additional learning that comes from just repeating all of those, you know what I mean? So let me see. So do they type branch? They type BR, Josh. So they're always typing the mnemonic, right? So the language, the instructions that would occur when you're programming in assembly language, right? So Josh, if you're writing an assembly language program, you would say BR, you wouldn't say branch, right? You would say add, and, JMP, LDR, those are the things you would type. They're basically, they're the big titles at the top of every one of the little pages that's about the individual instructions. Same thing. And if you want to double check that, you can just, when it says how the assembly works, that instruction's right there. Okay. What else? Last one. This is the last one, and it's sort of important. Because this is one of those things that maybe you just don't think about it too much because you're just young, you know, a lot of you, some of you are really experienced and you've been around the block doing code stuff, and some of you not so much, and a lot of this stuff is really, really new. Well, my opinion, you ought to be able to walk into our program, take 1400 as an absolute novice, having never touched any of that ever, and be okay getting a degree, becoming competent, and there's a lot to learn in 4 years, but you ought to be able to do that. So there's no assumption that everybody just knows all the things at this point, right? There's a lot of things I presume you're not going to know. And if you do already know it, good on you, might, and we can keep going. But there is a difference between a word processor and a text editor. And the bottom line is that a word processor not only has your characters in it, but it's got a bunch of other crap, okay? Other file formats, graphics files, all these things, they've just got a bunch of numbers and crap that if you're doing a thing in like a Word doc, there's just stuff in there that Word knows what to look for. Or if you've got an Excel spreadsheet, and one of the best ways, let me see, I'm sure if I've got like a live demo here for you, but I'm going to do a thing here where I'm just going to go, I'm just making a Word doc right now. And I'm going to save it. It's just called this is a test.docx. And let me bring it over here so we've got it handy. Okay, this is it. That's it, okay? And again, I don't expect you to, I can blow that up, but I think you know what it is, right? Let's make it a little bigger. All right, that's it. That's Word doc. Now let me do the same thing in a text editor, like, what do I normally use? BB Edit. I don't think there's anything, especially sacred about BB Edit, but other than, it's not. It's a text editor and it's not a word processor. The difference is the text editor is only going to have clean, straight up text and not all the other crap. I'm just going to show you what I'm talking about. Okay, now can I separate this guy out? Yeah, I think, actually, let me do this. Got to close these other tabs. Hang on a second. I thought I saved this thing. One moment, please. Yeah, for some reason, oh, it's because I'm a dummy. Here we go. All right. So if I go, yeah, okay. All right, here we go. Now this guy, can I make that guy bigger? Yeah, I'm blowing that guy up. Okay, text editor, word processor. What's the difference other than the interface? Well, this guy here has, now that's actually text edit, and that's not even a good example because, hang on, I don't want to use text edit. I want to have this in BB edit, which I already know is a clean text editor right there. Okay, there's BB edit. Okay, here's what I want to try to do, and this is the goofy thing that'll be sort of cool, I hope. What I'm going to do is I'm going to open BB edit, the BB edit one, the this is a test.txt, and I'm going to open it with what we call a hex editor. The hex editor I am using is something called hex fiend. It seems overly aggressive. I don't know, but that's what my currently favorite hex editor is called, hex fiend. Okay. Now, what I want you to look at, see what's in here? This is hex fiend. All right. Now, what hex fiend does is it separates just for typographical, just for ease of reading. Okay. That space is not a thing. It goes, okay, somebody real quick got an ASCII table? 5.4 ASCII. What is it? Wait, hang on. I have the technology. Hang on a second. Okay, this is the most butt ugly ASCII table in the history of all ASCII tables. Okay, apologies for the bottom ugly ASCII table. Here we go. All right, but that's the one that I had handy. It's really, really ugly. Okay, that's 5.4 hex, by the way. Hex, not decimal. Okay, there's an ASCII table. Hex is on the right. 5.4. Oh, there we go. It is capital T. I know you can barely read that, but that's capital T. Oh, look, capital T. 68 hex. 6.8. That's lowercase h. Do you see a pattern developing? That's it. These are literally just the ASCII values right there. This is a test. 2E, 2E. 2E or not 2E, the period. That's a period. Boom. It doesn't show you the end of file marker or the things that are part of like the operating system, the file system. Okay. But you see it? Clean, right? Super clean. Okay, now let's go contrast. This is a good little interlude. I think we always have to do this at some point. Okay, what I'm now going to do is the same thing. I'm going to open the doc file with hex fiend. Come on. Oh yeah, little uglier. Here we go. There's the doc file. Look at the comparison. Now, do you understand that that's all I did? That's all I did right there. Okay, I typed, this is a test, period, and I saved it. Oh, do you understand what I'm saying to you? That's all I did. Now, where the crap is our stuff? Also, how big is this thing? How big is this stupid thing? Let's go look. Okay, this is a test.txt, 13 bytes. Like when you just look at it on my hard drive, 13 bytes. This is a test.docx, 12K, 12,000. Okay. I mean, here, just check it out. Again, it's a little hard to see, but look at this. Look at this bad boy. 11,736 bytes. Okay. Now look at this one, the text file. Side by side. 13 bytes. Okay. One of these is not like the others. Okay. You get the difference? That's your Word doc right there. Now, so it's all the other crap. It's all the other stuff that it has to save away. Oh, there's like blah, blah. You can see some text. You know what I mean? You see some text in there somewhere. Word settings, blah, blah, doc props, web settings. It's all this crap that gets dropped into any Word file. Isn't that amazing? And what's interesting is I don't actually find, I mean, this text is in there somewhere. I mean, we got to search through 12K to find it. A lot of times you can, depending upon what you're looking for. I was just wondering if we could maybe find the text in there at all. Like, why wouldn't we find it? Well, they might have encoded it in some other way. They might have used some other thing that is sort of like known to Word for how they map and hang on to, all those characters, because they've got to deal with like font, font types, font sizes, there's all that formatting crap that you got to hang on to. And yeah, man. Yeah, can't even see it. Can't even see it. I want to do
Like
one.
you showed me that, I almost like had a physical reaction of wanting to throw up.
Yeah, understood. Now what I'm going to do is I'm going to take this Word doc and I'm going to save it as a PDF. So now I've got, there's our Word doc back, but now I've got, here's the PDF of the same thing. Okay. So let's hex fiend that bad boy and see what's inside. The hex, by the way, the PDF is 14K. The PDF is even bigger than the Word doc. Gonna open this thing with hex fiend again. Now this is the PDF. Notice that up top here it says percent PDF 1.3. That's probably version number. Let's take a look if the text is, a lot of times in a PDF, you'll see the letters. See, stop me if you see it before I do. I don't see it. Oh, author Charles Knudsen right there, right? Creator Word. So there's that other information stored in the PDF. All right. All right. Other stuff, some font stuff. Yeah. Yeah. So you get it? Do you get it? Okay. So what I don't want you to do is write your program in Word. Save it and then try to give that to the LC3 assembler. It's going to start looking through all the crap and try to understand it. And it's not going to make any sense. And it's going to puke. And you're not going to know why. And I don't see this as a test anywhere in here. I'm sure this would change if I OCR'd it. So you can do like the character recognition. A lot of times you do see text in here in PDFs with with a gap between, like a space between, like T space, H space, I space. And it's because of double byte characters, where you use, instead of the 8-bit ASCII, you use a 16-bit double byte, which allows you to do all kinds of, of international fonts, Chinese characters, everything. All right, is everybody nauseated yet? But do you realize that everything we've talked about in this class is actually converging in this moment here? Like really, because you realize these are all just hex values and the values mean something. And if you were to go look up the spec for PDF, which probably exists, that there's going to be, a little number, and there'll be somewhere here, there'll be like a length. See, like that length? Somewhere there will be like the length of the whole file, or where to look for. It's just going to be information that the developers of PDF decided to embed in the file. Okay. Have I blown everybody like crazy? Hopefully the panda's gone nuts. Thank you for the brain, Alex. Josh, Notepad. I don't know if normal Notepad works. Do I have normal Notepad? I have Notepad++. I don't know, but there's an easy way to check, okay? How would you check? Who asked that question? Josh. How would you check, Josh? Oh, Texas asked, would Notepad++ or Visual Studio, I'm sure would work. And I believe Notepad++. How would you test? How would you test? Real quick.
Do you just check the file size?
Right? If I type this is a test and there's 13 characters, my file size ought to be 13 characters. And if I'm really doubting, I can get a hex editor like HexFiend and just open it, and then I know for dang sure. Put it this way, if the editor you're dealing with has like formatting, like bold this, change the font size, etc., it's probably not a clear, just a plain text word text editor. Okay? Because plain like with BB Edit, I can't do anything. There's no formatting. There's no nothing. It's just the ASCII characters. That's it. So really clean. So I do all of my, text editing stuff with BB Edit. Again, there's a bazillion text editors. I did say bazillion, not Brazilian. There are also Brazilian text editors. Okay, let me clean up my mess here. I feel like it's the 90s and a bunch of pop-up ads just went crazy on my system. Let's see. Get rid of that. We don't need the ASCII table. Get rid of that. Get rid of that. Okay. Whew. That's a long way around saying this right here. Don't use a word processor like Word or anything else that has formatting stuff in it to write your program. Okay. All right. Let us do a little LC3. Walter, we gotta do the hosting on our modified version. We gotta do that. In fact, Walter, we had to touch base maybe for just a minute after class. Here's how I find the one. By the way, I'm going to provide you a link. There are some things we've added to this LC3 simulator that are better. And I want to be really clear. So this is it. You just go LC3 simulator, and right there on GitHub is, for my money, the best one. I've tried a few. I like this a lot. And our author on this thing, I just want to give a shout out to, because, and I don't have time, but if you go back to LC3 and if I just go there and I get rid of that executable, okay, this person right here, William Chargin, don't know him personally, and whatever, I don't know, right? He's at Google Brain, blah blah blah, worked at different places. I just want to say that of all the ones, again, Mr. Chargin is not paying me for this promotion. I just want to say props to him for making a really, really good simulator with a high degree of usability, and it is my preferred one to use. There are a handful of things that I don't like, but it's open source, and so we've actually made some changes to that. Okay, and then right. So Spencer and some others are dropping some comments about Visual Studio, LC3 extensions for Visual Studio. So if you're already using, now if you've never used Visual Studio, there's that little bit of, right, or Eclipse or whatever, there's all these like, whoa, you're suddenly in the cockpit of a 747, right? And it's a little cumbersome. But again, I want to thank William, like really sincerely, for doing just one hell of a great simulator that is really, really usable. And his code is really easy to understand. It's just great stuff. Okay. I would hire this guy. You know, so, drop a link. Are you talking to Alex? You're talking to Josh, right? The extension stuff, right? So, or do you want a link to the simulator is on Canvas, and you can also, I'll drop this, and I don't know, again, Alex. Yeah, okay, but it is a good reminder, and just for everybody's edification, that's the link to the executable on the web host thing, so you can run it from there. Okay. So I want to just draw your attention to a couple of things here in this little interface. I hope that's, I can blow this up just a little bit, but at some point you lose, utility. Okay, so memory. This is just all the memory locations in the LC3. I can go to location 0 all the way to the beginning, and there's some stuff down here, which you don't know what that is yet. The default on this one is to be here at hex 3000. It's just cleared. Memory is cleared. In order to clear the memory, by the way, if you ever need to like just reboot the machine, just refresh the web page and it'll reload everything and everything will be zeroed out. Okay. What else? But you can actually like put stuff in here. Okay. Like for example, right here, I can edit the value at this location. So let's say I want to do an add instruction, right? Which is 0001. So the first hex byte would be 1, and everything else is just zeros, right? R0, everything is just zeros all the way out. Does that do like a literal value? I think that'll do, I can't remember which one is it whether the bit is, when the bit is 0, do we get the immediate value? Well, we'll find out right now. Okay, no, when that bit is 0, so it then will tell me what the instruction is. So that is an add R0, destination address, source 1, source 2. The format on assembly is exactly the same as in the instruction itself. So I just wrote a little program here. Okay, now let's do, this is going to double. It's going to take R0, add it to R0, and put the result in R0. But let's go to R0 here, and let's put, 2 over here. So I can see all the registers. I can see the program counter. I can change it. The instruction register. What is the PSR? We never talk about that. The control codes. Okay. And all the registers. And the others are all zeroed out, but register 0 has a 2 in it. So let's just do it. Now, here's the thing. I can say run, which just takes off and runs your program. Okay. I can also finish a current subroutine. I can, these two become really important. Fully execute the next instruction means if it's a subroutine where I'm going to jump somewhere, I'm going to jump, do it, and return back and do all of that. But if I say step and it happens to be a subroutine or a trap instruction, it'll step into the subroutine. So this steps around a subroutine, and this one steps into the next subroutine. But let's just do this one. If I say step, notice what happened. R0 got doubled to become 4. We executed the instruction. The program counter is 3001 now. The instruction register is the last thing it had in it, which was the value at location 3000. Do you see it? That's pretty much it. That's it. Now, the other thing you can do is I can click this button down here, assemble. This, I can either type right here, I can type here, like I can say, first of all, I can say .orig. Remember we talked about the pseudo-offs. I can say .orig right here, which is going to tell it where to put what I'm giving you. So I can say .org, and I can say, add R0, R0, but I want to use, the value 4, okay? And then I can go .end. This doesn't have to be capped, but okay? I can then go assemble, and it goes, oh, that was assembled correctly. And it's going to put that instruction into 3000. But 3000 already has an instruction. What's going to happen to it? Answer, it's just going to get overwritten. I just wrote over the top of it. If you look at that's what I wrote. And by the way, it's still there, over there. So like, I might do a thing where I want to go add R1, comma, R1, comma, 5. So, right, I'm gonna put, that's gonna put a 4 into R, well, it's gonna add 4 to R0. Let's assume R0 was already emptied out. Okay, now watch. Okay, let me clear the registers. See, I can just clear them all. I can reset all the registers, which will clear the whole system. If I reset all the registers, program counter in this simulator just defaults to 3000. And the control code always starts as Z. Instruction register is always 0. Okay, I execute the first one, and now there's a 4 in R0. I do the next one, look at R1, boom, there's a 5. Okay, but what happens if we don't have an assumption that our registers are 0 before we got here? So I can go and R0 with the value 0. And I can do the same thing with R1. So I'm just going to clear R0 first, right? By ANDing R0 with the literal value 0, putting the result back into R0. I assemble. It's going to tell me if I make any mistakes. Like, let me go back. If I go, how do I do that redo? No, I don't want to load into the simulator. I'm going to go back here. There's my code. I say assemble, and it goes, oh no. Line 2, you got an invalid register specification. Like, it wants a register there, but or a literal value. One of the things I want to play with also is just some of the error codes and stuff as we continue refining it. All right, but I want to fix that little syntax error. Now, see what I've got? I'm clearing R0. So let's just do it. If I step into this one, R0 goes to 0, and now I add 4 to it. R1 goes to 0, and now I add 5 to it. I don't need to worry about finishing or putting a halt instruction. I don't need to do any of that stuff because I'm just stepping through to show you sort of some of the ideas, okay? Texas, I honestly don't know. I don't remember. I think I may have known, but I've never lectured about it, and I don't actually know. So you can win the chat, Texas, if you wanna find that out. I really don't know. It seems program source register seems entirely plausible. I don't know. Anyway, but you get the idea. That's it. That's the whole thing. Okay, now we've got about 7 minutes, and we can do another help section where we just meet at a certain time. Evening is probably best, and basically just anybody that wants to come ask questions. But you understand, this cannot be a spectator sport in the end. You got to pull this up yourself. Okay, what does it do, Texas? Program status register. By the way, I'm sure it's in that appendix. I'm sure of it. Process status register. Yeah, we would do the help section on YouTube, Gabe. Absolutely. In fact, there might even be an older help section I've done already on the LC3 that you can go find on my channel. In fact, based upon whatever that was, I don't know. Maybe I don't have to do this again. Oh, interesting, Josh. If the simulator is operating in supervisor mode or user mode. Okay. Well, I obviously haven't played with that, and it's obviously not, critical to what we're doing here as far as the class. Okay. Some other things though. Okay. What about the console and what about the keyboard? What about the Okay, you realize that we've never had the same. I mean, my money's on Walter, but we haven't had the same exact expression twice. We got program status register process status register, processor status register. I don't know. All right, here we go. Now we're going to talk about trap instructions on Thursday, but what I want to just familiarize yourself to. Okay, yeah. So Walter wins the chat on that one, but some fine efforts. All right. What am I looking for? Oh, yeah. I wanted to grab the appendix. Let us grab the appendix. Actually, I want to do two things. One is, let me pull up the instruction set again. Processor status register containing information about the currently executing process, privilege mode, priority level. Okay, that's cool. And again, when you get in here, you can see these are the instructions you're going for. These right here, not including the plus sign. Add and BR, JMP, JSR, JSRR, etc. Okay. Okay. Oh, I wanted to say this. The other thing I can do raw. Raw wants machine language. It wants binary numbers. Gabe has the correct. Oh, but Gabe's still trying to win the chat, which I think that's a good honorable mention there for pina coladas. Anyway, you can drop hex code here. You can drop binary code. Like let me give you an example. Like, okay, let's go 5020. Let's do another 5020. But here's the thing. With this raw, the very first number it uses as the dot origin. So if I want this at location, where am I? Where was I? We did 1, 2, 3, 4 instructions, I think, right? So let's go 3008. So if I go X3008, it'll put that instruction at location 3008. Oh, not a valid character. Oh, because it already wants it to be hex. Yes, yes. Okay, notice that down at 3008, it put that instruction. So I can shove it in as binary or hex. Oh, let's go one more experiment here. Let's go and do this at 3007. But now I'm going to go 0011 and see if that works. Yeah, at location 3007. Wait. 300A? Oh, what happened? What happened? Oh, it's because I'm doing the raw thing and because I had the spaces, I think. That should be where it's going. That should be the first thing and that should be the second thing. Yeah, not 100% sure. Obviously, it put that into different spots. Why? Oh, it's because these are each 16 bits. That's why. Yeah. No, what I really wanted to do. Yeah. Anyway, you get the idea. We don't have time to tear this whole thing apart. But what I want to do was show you again, go back to this document, which is in the book, also on Canvas as just a pulled out appendix. Okay. These are the trap instructions. And there's a trap vector, which doesn't mean anything yet to you. It will on Thursday. But the LC3 lets you say, instead of having to say trap 20, trap 24, trap 25, you can just say halt. And let's do one example. Okay, let's go over here to assembly and back to this program. And I want to go halt. By the way, forgive my indentation. It's ugly. Okay, I load it in. Now notice that it put in my 4 instructions and then a halt instruction. What is the halt instruction? 1111, that's the opcode for trap, and the hex value 25. Okay, that's the halt instruction. But I was able to just say halt. I can also say get C and out and in. The ones that you care about are more than anything at this point, get C. You're not going to want to use in, okay? Because in clogs everything up with its own message. Let me give you one example, and then we got to cut loose here. If I go to the assembly thing, I do that, and then I just say in. Okay, let's assemble it, and let's run it. Okay, if I say run, input a character. That's not the message we want to give to our user. And then if I input a character, it will take the character. By the way, it's going to put the character, spoiler, it's going to put the character in R4. Sorry, R0. And if I go, now the problem is this thing's going to take off and do a bunch of ugly stuff. But if I just go K, oh, it stops. Okay. And it trashes everything. I got to walk through all that to show you why it's doing all that. Anyway, if I unhalt and I reset all the registers, I'm back here with my little program. Oh, I did have a halt instruction. That's why. Oh, let me do this. Let's go next. When I get to the in, I'm going to say next, which is going to go to completion. I then say K, takes me to the next instruction, and that R0, that's the ASCII value for the lowercase k. Okay, last thing, and then I'm going to cut. Let's go back to our things here. Out, write a character in R0 to the console display. Okay, now notice that what this thing did was it did, hang on. Okay, when I said input a character, it actually echoes it. But what I want to do is not in, but what is it? Is it CN? No, what is it? That's not it. Yeah, it is. Hang on. I want get C is what I want. It took CN, but I don't know exactly why. I'm going to do get C. All right, here we go. Let's do it. I can also clear the output to just give me a clean console. I go next, and now I do get C. Okay, so I'm over on the console. I type K, and it took it in, because see, there it is over there in R0, but it hasn't spit it out. I go next, and it spits it out. That's the two-step right there. It's literally get C, and the value goes into R0, the bottom half of R0. And then when I go out, it takes whatever's in R0, spits it out to the console. We're out of time, but we can do more of this, okay? But you have to get on the LC3 simulator and do this. You have to do it, okay? You have to do it or you're doomed. Okay, we're out of time, but I think it's good. I hope we didn't talk a lot about the design of the program, but I want you to give that some thought, and then maybe, I don't know, Wednesday night, sometime soon we can do kind of a live help section to talk about the design. And again, there are some help sections just from semesters past on my YouTube channel that you can go look some stuff up for talking about the design of that program. Okay.
A really quick question, just
yeah,
really quick over here.
Yep.
Maybe I missed this because I don't know, days off, butterfly or something, but is there a due date for this program, or is it just done by the end of the semester?
End
like
of the semester.
Else?
Yep. End of the semester.
Sweet. Thank you.
You bet. Okay, I'm out. Lunchtime for me.